It looks tough when you see it for the first time, but if you know these two formulas, then you can solve it in 2 minutes. So the formulas will be these two. That is log x, y, z. When it is in the product, you can write it as its sum, log x plus log y plus log z. But when you have something as its power, then it will be replaced as its coefficient. So x power m will become m log x, y power n will become n log y, r power z power r will become r log z. So this is the formula that we have used here. So if you know these two, then we can simply solve this. So let's move on to the question. Here, as we can see, it is 25. Here 3 power 3 can be written as 27. So 27 is 25. So the difference is 2xy. So if you add 2xy, then you'll get the proof that is asked in the question. So let's write it. The question as it is: x square plus y square is equal to 25x square. Now if you add 2xy on both sides, adding 2xy on both sides, so it will become x square plus y square plus 2xy is equal to 25xy plus 2xy. Now this is in the form of a square plus b square plus 2ab. So it can be written as a plus b whole square, that is x plus y whole square. Now 25 plus 2 is 27, and these are like terms, so it can be added. So 27x y. Now to get the proof, you just need to add log on both sides. Adding log on both sides. So log x plus y whole square is equal to log 27x y. Now as we have seen up there, whatever is there in the power will become its coefficient. So it will be written as 2 log x plus y. Now this is in the product, so you can write it as its sum. So log 27 plus log x plus log y. Now 27 can be written as 3 into 3 into 3, 3 cube. So log 3 power 3 plus log x plus log y. Now again, the formula that we have seen up there, it can be written as 3 log 3 plus log x plus log y. We can write this as it is, 2 log x plus y. So this is your required proof. Thank you.